So let me introduce our second speaker, Dheeraj, who works at Red Hat with over 7+ years of experience in automation, cloud, and containers. He actively develops and designs architectures tailored to meet customer needs.
Thank you, Hammer. I'm just sharing my screen. Very good morning, everyone. Thank you for joining and giving us time for us to sort of provide certain information on the community. So I'm Dheeraj Reddy. As Hammer just mentioned, I work with Red Hat and I work as a solution architect and mainly looking at customers in APAC region. So today we'll be discussing about a project called Open Cluster Management. So the agenda of what we'll be discussing today would be introducing what the Open Cluster Management as a project is, what is the need and why one need Open Cluster Management, and finally to end it all, we'll be looking at the features of OCM in short form for Open Cluster Management, wherein we'll be looking at its features like Multicluster Management, Application Lifecycle Management, and how we can govern or inform or enforce multiple policies and making multiple clusters compliant. And finally, we'll be looking at the cluster observability with respect to how we can look at the utilization or the complete metric data of the multiple clusters from a single pane of glass. So quickly going ahead, so before we touch upon what Open Cluster Management is, I would like to just take a few seconds to explain on the Kubernetes part, because this sort of lets you understand why one needs Kubernetes or microservices and why are we ending up with a project called Open Cluster Management. So as many of you have already introduced, that many of the people are aware of the Kubernetes. So quickly taking some time into this, please feel free to add anything if you would like. So as everyone know, Kubernetes is an open source container orchestration tool, which helps developers and the administrators or even the DevOps engineers to sort of manage, deploy, and scale their applications on the container platform, right? So also this Kubernetes cluster provides us that particular flexibility to be able to deploy it on any of the platform, like be it the physical servers, the virtual machines, the private cloud, public cloud, or even on edge, as currently we know that Kubernetes, we can deploy it on edge devices as well. So from the Kubernetes platform, we get that flexibility to absolutely deploy it on any platform available in the market today. So if the way of working in Kubernetes, maybe if I have to sum it short, the Kubernetes sort of takes a declarative specification file and deploys a particular application on how exactly it has been defined in that particular file. So it might use an image, or it might use an YAML file, a var file, a jar file, or even use certain strategies like source to image and sort of deploy your application by cloning a particular some of your code from the Git repository or any other repository for a fact, and then create an image and deploy. So we have multiple options in which we can deploy the applications, and this particular file helps the Kubernetes platform to sort of constantly check the end application outcome to the file or the deployment YAML file that we declare on how exactly the end application should
Sorry
run.
to disturb, Dheeraj. I think your presentation is blank. Okay, maybe it's coming now. I don't know. Maybe the rendering issue. Sorry for that.
Sorry, Hamad.
No, yeah, now we can see your screen.
It's good now, Dheeraj. In between your presentation was a solid white screen. Now we can see it.
Sure. Okay. Please let me know if you face that again. I'll just go ahead maybe if we are able to.
Sure.
So yeah, and the major features maybe the reason why there is a lot of talk about this particular platform in the market is because certain features that the Kubernetes platform can guarantee, like high availability for your applications, which is like the biggest important thing for any of the developer or for in fact the enterprise as well. And the scalability aspect, it provides us the easiest way of one can scale their application from be it one replica count to 100 replica counts. So it provides us the scalability, and also the most important thing is the disaster recovery. So this platform helps us recover in case if there is any failure at the infra or at the DC. So there are certain solutions wherein we can take a backup and restore the complete cluster, making sure that our applications or the critical applications is not completely destroyed or deleted from our enterprises. So all these features sort of makes it one of the hottest tool that is available today in the market. Uh, and if we see the transformation, as we know, there is always a need for. Amul, just to confirm, I've just changed the screen. Sorry, the slide.
Maybe we can
You're
see.
able to see the slide?
It's rendering properly. Yeah.
Yeah, sure. Thank you. Yeah. So with the change in time, so we have always come with certain tools or certain processes into our day-to-day activities, which make us our life easier and sort of create multiple technologies and applications to sort of help the community or the people or the world, right? So if you see, it's not just at the application level. We have also made a lot of transformations from in play in terms of the infrastructure or the processes, be it from monolith to the microservices, or a hosted environment, or a data center to hybrid environments, and the development models that we follow from waterfall, agile, and now DevOps or the DevSecOps that we say. So there is always a constant move, and this sort of brings us a rise in the adoption of containers and microservices technologies. Wherein we are taking all the monolith application, the legacy applications that we have, and sort of trying it to modernize and making it into multiple containers or microservices to sort of modernize our applications in a way that sort of provide scalability and manageability to the end user as well as the creator and the administrator. But there is a small catch here. So with ongoing new technologies, if we are trying to use this as a technology, there is a possible way that we end up with maybe hundreds or thousands or even lakhs of container applications or microservices that we would have developed in our organization, right? And so to sort of manage them, it becomes very tough for be it the developer or be it the administrator, by just writing some scripts or using certain tools that have been developed in the organization. So all this sort of comes up in the, it's been taken care by the Kubernetes platform, where we can manage or scale or deploy these applications and look at it from a single pane of glass, which is the Kubernetes cluster. And thus we result in creating multiple clusters at our organization. At a bare minimum, in an organization, if we are adopting something, a container orchestration tool, at least we will have 3 different clusters, right? Be it a the dev stage, or be it the QA or the test environment, and then finally the production environments. And let's also assume if there is a scenario where we want to replicate.
Sorry, Dheeraj, I think growth of clusters we see on the screen, but okay, now it has been done. So I think just a delay, I believe. Yeah, now it's visible.
Can I just unshare and reshare it once again?
Yeah, please.
Yeah, if possible, the whole if you can try the whole screen sharing, that might work better. Yeah, this is better actually.
This is good now?
Yeah, so far so good.
Yes.
Yeah. Yeah. So where was I? Yeah, at the geo replication. So there could be many scenarios where we would have to replicate or sort of deploy certain applications in a geographical different regions, right? So that would also again end up with multiple clusters. Though Kubernetes provides a solution wherein you can deploy a particular Kubernetes cluster with, let's say, a virtual machines on different availability zones in a region. But when we sort of try to deploy it on multiple other regions, we have to create multiple clusters. And as a minimum, we can say one cluster maybe creating multiple projects or multiple teams and giving it access to the developers to sort of use that particular cluster to scale and deploy their applications. So this sort of adoption for Kubernetes brings in multi-cluster at an organization is what I sort of want to pitch. The reason for that could be many things, as I just mentioned earlier, and the other reasons could be because of latency, the vendor lock-in, or addressing certain industry standards, or if one organization wants to sort of enter into a multi-cloud or an hybrid cloud, which is a norm for today in the enterprise organizations. So that would end up with multiple clusters, correct? So if we end up with multiple clusters, what happens is that though Kubernetes helps to manage applications, but adoption of the Kubernetes ends up with driving us to sort of create multiple clusters. It's not just that, we have certain other issues along with that that we have to look at when we create multiple clusters in an organization. Few are as added into this particular slide. How do we create or delete or sort of manage multiple clusters? Because there would be n number of dashboards for each Kubernetes cluster, be it from the application deployment, the CLI, the logging metrics, or the Prometheus. There will be 5 to 8 different sort of dashboards that one has to manage in an individual cluster. So what happens if you have like 10 or 100 or thousands of clusters in an organization? It sort of becomes very tough to sort of manage, right? And also how to keep all these clusters compliant based on the policies or based on the compliance that the organization follows, to sort of enter each cluster or to create certain scripts to manage all the clusters together at once and to drive a particular policy and making sure all the clusters are compliant. It sort of becomes very tough for the developers as well, correct? So that's one issue that one has to face. And like certain resources that one create, maybe in a dev environment for a particular application, they have created in quota, where that particular application can easily run with respect to utilizing the CPU or the RAM that is available in that particular project. But whereas if there is a change in the production, that would end up bringing down that particular application. So how do we create a common resources across multiple clusters? So these are certain challenges that one faces in the day-to-day operations when we sort of adopt to multiple clusters, correct? So how to overcome this is been a big ask in the community, and the community has come up with something called as the open cluster management, which is a single pane of glass that sort of provides you a particular window where you can source tens, hundreds, or thousands of clusters and manage them from a single window, as well as you can create and deploy applications using the placement policies, and also delete clusters or delete applications. And finally, you could also get the observability of different or multiple clusters that have been attached to this open cluster. So as a definition, if you go by, it's just designed to help developers and the administrators to manage their applications or that run on multiple Kubernetes clusters. Just before we go ahead, any questions so far? Okay, yes and no. Sure. So this OCM as a project provides certain API primitives that allow these functions to sort of provide certain APIs like cluster inventory management, which helps us to manage an inventory of different clusters like QA, dev, prod, or different regions that have been deployed in. Or let's say if there are 10 clusters which have been divided into few in on-prem, few in hyperscalers, and few in public cloud. So this one particular cluster inventory API allows us to sort of source all these particular clusters and bring them into a single window from which the administrators can easily manage and look into the operations aspect of the clusters. And the other API that is been provided is the cluster workload placement. And the third one is the cluster workload distribution. So both these APIs help in how a developer could place a particular application and distribute it into a set of clusters or an individual cluster that is the requirement of the developer. From the architecture perspective, the OCM follows a hub and spoke model. In other terminologies, you could say just try and remember something like an cycle wheel. At the center, there would be a hub, but there are multiple spokes that are connecting the edges of the cycle tire, right? So similarly, in the OCM, we have something called as the hub cluster and then the managed cluster. So hub cluster is the central cluster that works as the control plane, whereas the managed clusters are the end clusters that we sort of get it connected with the hub cluster. And hub clusters can be provided to the administrators, which can be which the administrators can take that particular window to sort of manage all the other clusters that have been attached to the hub cluster. So if we quickly look into the architecture, as you could see here, so the hub cluster is the control plane, as I was mentioning, and on each cluster, we have something called as the cluster manager, and on the managed clusters, we have something called as the clusterlet. So this is in the same terminologies as we see in the Kubernetes. Let's say, as we know that we have something called as a Kubernetes API server, right? And we run a kubelet agent on each of the worker nodes in Kubernetes. So similar way, we have this cluster manager where it manages the entire hub cycle, and whereas the clusterlet, it sort of runs on each individual managed cluster and allows it to connect with the hub cluster and get the data to and fro from the hub cluster. So as you could see here in the cluster manager, we have the registration controller and the placement controller, which helps us to register an end cluster and attach it to the hub cluster. And also the placement controller allows us to place or deploy a particular application using certain components or the aspects like the labels, which allows us to deploy it in a specified cluster at the Kubernetes. And it also comes up with certain other policy add-ons, the management add-ons, wherein you can govern using some policies and how the application should work, how to scale, and all those things. You can also add on multiple management add-ons into this particular hub cluster. And from the clusterlet, as you could see, we have the registration agent which helps us to register this particular individual managed cluster to the hub cluster, so that it can be governed or managed from the hub cycle. And also the work agent, which checks with the hub cluster at each individual go on how exactly the placement or how exactly the policies has to be governed inside the managed cluster. So in short, we could say these are, I'm just showing 3 different managed clusters. This could end up with 1,000 or 10,000, but the administrators can just manage all those clusters from this particular single window to all only. So some of the features that the OCM has is the multi-cluster lifecycle management, the policy-driven governance, advanced application lifecycle, and the multi-cluster observability. So we will drill dive into each of the individual use cases and try and understand how each use case sort of attaches to this particular solution. So as you could see on the right, so this is how sort of looks as a dashboard, wherein you can see the observability using a Grafana dashboard, where you can see the governance using the governance dashboard, whether if my cluster is compliant or if my applications that are running on top of these clusters are compliant or not, and a topology view for your applications with respect to the components like replica set, and everything would be added to the topology view, so that it would help the developer or the administrator on how the components are connected and what are the components that have been utilized by the Kubernetes cluster. And finally, if we are attaching multiple clusters, so since there is no vendor lock-in, whatever the cluster that supports the CNCF, we will be able to source and attach it to the hub cluster. So we can see multiple clusters that have been created on these different hyperscalers. All these will be able to attach to the OCM dashboard. So if we see at the multi-cluster lifecycle management, so from the role perspective, who would be more concerned about, like let's say an IT operations guy. So there will be certain questions that would drive into his mind, right? Like when we have multiple clusters, so he would say, how can I manage the life cycle of a multi-cluster? So our organization has come up with this particular solution that I have to create multiple clusters, and for different so for different teams, we have to create multiple applications, and this ended up with multiple clusters. So how do I manage, be it on-prem or some of them are in cloud, the private cloud, and some in public cloud? How do I manage them, or how can I simplify, understand the cluster health? So that's something that has to go on day-to operations, and each individual day, the administrator takes a lot of effort in sort of checking whether all the clusters are healthy or not. So how easy I can do. So these are certain queries that might run from the role perspective. And finally, if there are any failures, how easily I can navigate to that particular failure and sort of correct it so that the cluster is running absolutely fine. So if you see from the multi-cluster management, so as a dashboard, you can centrally source the different clusters, Kubernetes clusters that are running across different regions, and can manage from a single window. And not just that, it also helps you to update the clusters. Once the source has been attached to the hub cluster, we can update each individual cluster if there is a new version coming. So the Kubernetes cluster follows a quarterly upgrade. So if we want to upgrade, you can do that from this same window itself. And if we want to delete any cluster, or if we want to create new clusters, we can easily do it using this particular multi-cluster management as a tab in the dashboard of open cluster management. And if we want to search any Kubernetes resources, like let's say, as you could see, there are certain uh, clusters created in the open source community OpenStack tool hypervisor. So if I just click on this particular OpenStack, it would take me to that particular cluster that has been deployed on OpenStack, and you can see how many master nodes have been deployed, how many worker nodes have been deployed, what are the number of applications that are currently running in this particular cluster. Is there any compliance that is missed in this particular cluster? Or if there is any particular application that is not running, it is going into a crash loop back, or if container image is missing. So all that data that one needs as an administrator to manage a cluster, with a single click here, we will be able to end up getting into that particular window and sort of see all that data, thus helping the administrator to sort of quickly troubleshoot and making sure that the downtime for an application or the cluster comes down drastically from the organization point of view. And from the application lifecycle management, so as you could see, maybe the developers, the DevOps, or the SRE guys are the ones that will be much more worried or much more concerned about this particular development processes. So how can I automate provisioning of an application or a cluster quickly to sort of test and deploy my applications? Or how can I place a particular workload? Let's say there is a set of group of clusters that I want to deploy a single application and test at one go. Can I do that, or should I need to go into each individual cluster and then sort of deploy that particular application? Or if I have to push automatically, is there a pipeline that I can just generate and then deploy a particular application, going through multiple cycles of testing, like deploying it in dev and automatically testing it, and if it is a success, going into QA and vice versa to the prod. So, and finally, looking at the topology view. So in microservices, as we know, it's no more in monolith application where a single jar file or a var file can deploy the entire application, the three-tier application, front end, back end, all together in a single window. But whereas we come into the microservices, it's a chunk of application, right? So there is n number of connectivity that happens between these applications. So is there a view that I can get from the tools wherein I know that these are the microservices that are getting connected to each other, thus providing me the end application result? So is there a tool? So these are certain queries that from the role perspective, these developers would have, and these are all taken care by this particular tool. So as we could see here, the application components are majorly divided into three subsets, which is channel, subscription, and placement rules. So channel is nothing but where the repository stays. Maybe it could be in the Git repository, a Helm chart, or an object store, where the YAML file would be creating. And using this particular channel, you can source your code and sort of deploy it in your application. Or secondly, could be your subscription, where it subscribes to a particular repository to deploy the end-to-end cluster container resources. And finally, the placement rules, which would help deploy the applications as per the placement rules that have been updated in the placement rules. So this tool uses something called as the labels. So during the creation or during the sourcing of an independent cluster to the hub cluster, we enable something called as labels and provide name to the cluster, like a label name equal to dev cluster or name equal to Kubernetes end cluster. And that sort of helps setting up a cluster set or deploying a particular application to a group of clusters using the cluster set. So so this placement rule plays a major and a vital role for the administrators or the developers to sort of manage a single or a group of clusters. So as you could see here, the visual representation as well is pretty much possible. As soon as a particular application has been deployed, it's no more just the application and the end route that one needs to sort of access that particular application. We also get different details that the components that are for Kubernetes are being utilized. As you could see here, the deployments, the replica set. So at what rate or at what stage of an application are we using what component, we will be able to quickly look at in terms of the topology view. And let's say if we want to just increase a particular replica count manually, one can just go to this particular topology and select this particular replica set and change the number of replicas. So it sort of brings us the complete consolidation of the microservices. As you could see, it's no more just the application that we see in the topology, but also the components that have been integrated to sort of get that application utilization has been given in the topology view for us. So if you see the placement point of view, if let's say if a developer tries to create a CI/CD pipeline and deploy that particular application, and that application has to be deployed on a multi-cluster setup that is being scheduled in an organization, or even in hybrid cloud. Like let's say here, my on-prem has to be deployed with the same application as well as my public cloud environments also. So we can create a pipeline with this particular tool. We can use the APIs to configure any of the CNCF supported pipelines and deploy the applications by providing the label concept or the placement policies that we just looked at, and can deploy these applications either in the on-prem or the hypervisor VM, be it on-prem or on private cloud, and on the public cloud. So the distribution plays a major role, and the administrators or the developers need not get into individual clusters, but can just walk it around from the single hub cluster. So before we go ahead with the governance or the policy-driven compliance of the clusters, is there any questions that I need to take?
I think we have about 5 minutes remaining. No questions in the chat so far. If anybody have any questions, please unmute and ask. Yeah, I think we are good.
So yeah, so let's get into the security aspect of the clusters. So we have seen making sure that each individual cluster is compliant to a certain set of policies or a few add-on security tools or policies that an organization might use, like something like HIPAA, CIS, or FISMA, PCI, right? So how can we integrate these particular policies and make sure the clusters are compliant, and how easy can I make it possible for the users is could be a issue for particular security teams. And also if there is any particular alert that needs to be generated, so we can also integrate this open cluster management with alert manager, Prometheus, Grafana, and sort of get that particular alerting mechanism, wherein let's say if a particular production application is getting utilized at around 80 or 90% of its resources, and we haven't placed any replica set, and we need to trigger an alert for it. So we can, how can I do all that particular alerting mechanism, or how can I run through the policies is what we'll be looking at here. So as you could see here, from the hub cluster, you can centrally set, you can enforce certain policies on the applications or on the cluster, the infrastructure as well. So we use two different policy structures in open cluster management. One is to inform and the other is to enforce. And the third one you can do with both inform and enforce. So inform, it just checks whether if that particular policy is success or a failure, or if there are any queries that you have written, it will keep checking the cluster or the application. And if there is a deviation from the query that you have written, you will be informed. And if you have already set up an automation process, wherein if we find this particular deviation, I want to enforce certain policies to make sure it is compliant. So you can enforce those policies automatically. And let's say if you want to inform and then get it enforced after you accept a particular pipeline or accepting that you can go with this particular solution, you could do that as well. So from the policy-based governance, so we have used something called as a policy engine. This policy engine is all driven by CRDs and controllers in open cluster management. Yeah, so as you could see here on the right side of the window, so you can create a policy, you can enforce them on top of the Kubernetes resources, and you get a complete governance dashboard as well, wherein you can see what clusters are compliant and what clusters are not. And even you can drill deep into if my application is running successfully or not, or if my application is compliant to the standards of my enterprise organization or not, or the image that is being used for a particular microservice, is it compliant or not, or is there any vulnerabilities in that image, and if so, how you can overcome or how you can enforce that policies to that particular image and make sure it is compliant. So all these you will be able to do that with the policy-based governance, wherein you can enforce certain policies and making sure that your end-to-end clusters, be it from developer environment to the production environment, are in compliant state. And finally, the multi-cluster observability. So as I was telling, by default, we can integrate it with the Grafana dashboard, wherein you can get the understanding of multiple clusters. You can create custom dashboards as the open source Grafana tool provides us with. So by default, there would be some around 8 to 10 dashboards that would be available by default, wherein you can just select how many clusters have been integrated with the hub cluster, what are the different amount of worker nodes that have been added into each individual cluster, or as a total subset of all the clusters that have been attached. And you can even drill deep into till the application or the pod or the microservice level. So you can select a particular cluster, you can get into a particular project or a namespace, and you can select a particular application pod and see the current utilization or what exactly is going on with that particular application from both application as well as the cluster level. I mean the infrastructure, bare metal or the virtualization VM level as well. And yeah, so you can, yeah, is that a question?
Yeah, we have one question from Oshi Gupta. She's asking how OCM differs from Cluster API, as both are used in cluster provisioning.
Okay, I'll take that in some time. I'll take it in a few minutes. Let me complete it and I'll write that down.
Sure, we have a few minutes remaining.
Sure, yeah. And finally, as you could see with all the features, why exactly one needs the open cluster management. So as I was telling, it's no more an individual clusters that the organizations or the community is using. So we have come across from using 3 or 4 clusters to now getting into the edge devices as well, wherein an organization might be deploying these clusters on a single virtual machine, and thus creating like thousands or 10,000s. And using these certain policies or this particular OpenShift cluster dashboard, you can scale the clusters, or you can manage the clusters, and you can destroy clusters, and also manage your applications and govern them by enforcing certain policies of the standard that we use at the organizations. So in short, the use the features that the Open Cluster Management has is the complete life cycle of a cluster, be it one or multiple clusters. You get to see the multi-cluster observability. There are tools like Grafana, Prometheus, Alert Manager that one can integrate it with and get the complete details. And you can also enhance the application deployment as well as the policy management, wherein you can deploy a particular application on a set of or a group of clusters using the placement policies. And finally, you can govern the policy by driving it using the policy dashboard that we get from the Open Cluster Management. So finally, these are the references that we have in the community. So these are all the details that we can look into for understanding or utilizing the Open Cluster Management. And this is a community GitHub repository where one can go and sort of understand the current development, or if you want to contribute, one can go ahead and do that in this particular GitHub repository. So that's all from my end. Yeah, that question I'll just read and then I'll take it humble. So that's all from my end.
Okay, any other questions? We are good. So thanks a lot, Dheeraj, for an excellent presentation on Open Cluster Management and walking us through the cluster solutions in place. It was an opportunity to learn from you. Thanks for sharing your expertise.